Welcome to my session. It's about logic apps and Black Friday. If you're expecting a security talk, you're in the wrong room. You have to go one floor up. My name is Aarjan. I'm from the Netherlands. If you see the beautiful tulip fields, that's just outside my hometown. We are very proud of that. It's beautiful for 1 month in the year. Yeah, Netherlands also famous for cheese and also some famous painters. And of course beer. We sell a lot of beer. And I work for a company called McCall. McCall is it's a Microsoft of a Microsoft partner who offers only Microsoft support for our customers. And we have offices in the Netherlands, of course, in Lithuania, and also in Germany. A little bit about myself. I'm a hardcore C# .NET developer, developing in .NET and C# from 2000, starting with the Alpha 0.0. And yeah, I like that a lot. But what is this guy doing a talk about no code of little code, and why I'm so enthusiastic about it? Yeah, let's find out in the next hour. If you have any questions, let's put them in the end if we have time. Otherwise, just find me outside the room or on the floor in the conference center. But to start, I would like to start with a little quiz. So would you all please stand up? We just ate lunch, we need a bit of exercise. Okay, ready? Okay, everyone not familiar with logic apps. If you don't know what logic app is or just seen a demo or something, please sit down. Oh, that's a lot. This session is not really an introduction into logic apps. You go a little bit further, but I hope at the end of the session you know why I'm so excited about logic apps and the serverless proposition of Microsoft. And then you know that you have to look into logic apps. It's really cool stuff. Everybody who is familiar with logic apps but only did the demo, etc., but not really used it in production, please sit down. Okay, cool. You're going to learn a lot. You're going to learn a lot. The rest of you guys, one more question. Who has worked with logic apps in production but only created them in the portal? So not deployed them through a CI/CD pipeline or something. Please sit down. Cool. The rest of you, come meet me after the session. We can talk some war talks and compare solutions, and maybe that's fun. So the rest of you can sit down as well. Okay, my talk today is 3 steps, 3 major points. 1, what's the challenge? What was the case? Why did we? What is it about? The talk is about real customer case. We did for a customer. Then we talk a lot about the solution, what we did, and at the end I will disclose the results, how we did it, and if it worked or not. And I also have some key takeaways, of course. So what's the case? Our customer started about 3 years ago with a new initiative. It was a big company who did a lot of B2B things, and they wanted to open a B2C channel on a web shop. So they invested in a lot of research on what's a good SaaS solution for a web shop. They selected one. They implemented one like a little startup, like a proof of concept. This particular SaaS solution had a lot of integration possibilities already built in the system. So they had the payment provider, they had product catalog, of course, a lot of integration also with the financial systems they were using. So there was a lot of integration already built in the system. But like every solution you build, you have to do some integration yourself. And in this case, because it was a B2B specialized organization, they didn't have a real warehouse capabilities to provide business to clients. So the business to customers sent out the orders themselves to customers. That's called, but there are specialized organizations for that, and they're called LSPs, or logistics service providers. They have rack space for you, and they do the order picking for you if you send them an order, and they tell you, give you the tracking code, okay, we shipped it with this shipping company to the customers, and you get the tracking code back. So that's an LSP. And of course, when you integrate that, you have to build some middleware to facilitate that. And they built a little middleware with some state in the middle. And the first solution was built on cron jobs. So every hour they pulled the new orders from the web shop, and they send it to the LSP, and the LSP would acknowledge them, and once an hour or every 2 hours they would put a file on their FTP system so that the middleware could pick that up and process the orders, renew the state of the orders in the web shop and send out some emails. But it was a success. Customers really liked the product, really liked the web shop, so it grew, and ambition grew as well, so they needed some more. They wanted to follow what customers did, so they included also an e-commerce marketing system, a system that sends out emails, and after 6 weeks, or after 2 weeks, sends, okay, are you still happy with your product you bought? And so to follow the real customer journey and entice the customer to buy more. You know, the emails you get, that you throw away immediately when you bought something online. There's a real system for that. And they also had to integrate with that, so they extended the middleware. So far, everybody with me? Okay, then it was a success, so they opened in another country in Europe a second web shop, and a third, and the middleware grew, and also a second LSP, and the middleware became bigger and bigger and bigger. Mostly built on cron jobs still, but you know, everybody has been in this situation when you start with something and it grows. It's not really stable. They only knew when orders were failing, when customers were calling customer care, so they had a problem. And then finally, in 2017, Black Friday, the whole system went down. They lost a lot of orders. They were busy fixing the orders for a month to make every customer happy again. At that point, last year, around this time of year, they came to us, so please help us with our middleware. We have a problem. Next Friday will be massive. We also have other big marketing campaigns ready to go, but we're not, the middleware is not stable enough. We're losing money here. And they had some requirements. Of course, the project had to be finished before Black Friday. It's the end of November. But most important was there were like three requirements. It has to be stable, it has to be stable, it has to be stable. We have to depend on it. There's real money flowing through the system. Second was, we don't want to know if there's a problem in our middleware if customers start calling, but we want to know if there's a problem. When it happens, we want to monitor that. Third was, it was a little bit of wishful thinking, but the middleware should be able to process 10,000 orders per hour. So that's also a big challenge. And last, yeah, okay, we now have a web shop. It works fine, but we have bigger ambitions. We want to do more marketing campaign, more combinations of discounts, etc. This SaaS solution doesn't provide us, so we're looking at a new web shop to implement a new web shop. So that were our 4 requirements, basically. So what did we do? We changed the middleware using serverless technology from Microsoft, mostly logic apps and some other components. And we also changed a lot of the cron jobs to events. So from a cron job with a stateful middleware, we went to a stateless middleware using event-based. We had still had some timed jobs because the LSPs, the logistics service providers, they're the kind of organization that have a very small margin, and they don't have a lot of budget to improve their automation. So there's some really old stuff there, like FTP sites where you put on a comma-separated file for the orders, etc. And they couldn't handle more than 10 files an hour, so we had some timing there. We needed to go. Let's talk about serverless a little bit. This is my definition. There are a lot of definitions about serverless. My definition is you have a full abstraction of the server and also of the platform and the runtime. You're not thinking about this platform and the service. It's event-driven and it scales, and it doesn't scale vertically, it scales horizontally. It scales really big. And also you have micro-billing. So you pay for every transaction, and that's, of course, for a web shop that has a lot of peak loads and then also slow periods. It's very good because you only pay for use. It's like the consumption payment plan. Everybody agrees with this definition? Okay. What are the benefits? Okay, the benefits of serverless, yeah, like I said, you don't have to manage your servers anymore, you don't have to manage your operating system anymore, etc. You manage your apps, and that's it. The apps run at the runtime, and Microsoft is manage them for you. Because of that, you also have reduced DevOps. You don't have, that's complete logic. If you don't have to monitor your servers all the time, you have less cost there as well. And you have a really fast time to market because a lot of the groundwork, a lot of the plumbing you don't have to build anymore. It's just about the logic in your app. And this also really paid out in our solution. We had a Scrum way of working, and we had a bi-weekly sprint. And every 2 weeks we could do in the demo show real progress. Also in the first sprint. In the first sprint we had a working system for one flow. It was actually the order paid flow, which I'm going to show in the demo as well. So really fast. And it was with 2 devs. 2 developers in 2 weeks, we could build one flow already. So we went very fast. It's also great for if you want to do like a proof of concept or to work with the business. Okay, maybe we have to do something like this. Okay, you can really prove your stuff. Now, what are logic apps? One of the 3 real serverless components in Azure. The others are Azure Functions and Azure Event Grid. It's basically a workflow. You design it in a designer, or you can program it in JSON. It's very declarative. It's also very resilient. Every action you do and you step out of your workflow, it automatically retries, and you can configure that, how many times, etc. so very resilient. So when one of the systems you're connecting with is doesn't work anymore or is in maintenance, the logic apps will retry a few times. Nowadays is a new feature. It's also very testable with static results capability. It stores the data standard for 90 days. So also GDPR compliancy is also, yeah, how you say that? It's taken care of, thank you. Because yeah, after 90 days, all the information is gone. If you want to store it longer, you have to do it yourself. You can also play with that period. It also has great built-in monitoring. I will show that in the demo as well. That is really, really powerful, and it scales out massively. We tried that, and I will show you also later. Logic apps, a lot of connectors available for logic apps. I counted them very quickly at 286 at the moment. And with the enterprise integration pack, you have even more possibilities. And also the pricing is very good. Price per, you pay per action you execute. So if you, for instance, you have a process that processes 1,000 service-based messages a day and takes about 5 actions, you pay, you can read it, about €4.5 or a little bit or more, $5 per month. And that depends totally on how often you use it. So it scales up when you have high load and goes down, we have low load. So that was setting the stage. What was our challenge? Now we're going to dive a little bit deeper in the solution. This was our basic architecture. This is one flow for the order paid event. Of course, you also have the order shipped event and also the order acknowledgement, newsletter subscriptions, account creation, all things, all that kind of operations, events happening in your web shop. And what we did, we bought first the event, and this web shop was very nice that had worked with webhooks, so we can connect to a webhook. One logic app, the main logic app, was the orchestrator. There, the JSON package came into the logic app, and from there, the flow would run. What we did was we converted the data coming in from the web shop. We converted it into a canonical entity. In this case, a canonical order. Now, the mapped 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 order translated object was put on the service bus with another logic app. It was a generic logic app we can reuse. And then it was put on a service bus topic. And so a service bus topic is like a queue with multiple subscribers. It's like a pub-sub mechanism with queuing. And we had one subscriber for the LSPs, or multiple for each country, or each LSP had its own subscriber on the topic, and also one for the marketing system, which is number 7 in the diagram. Basic architecture. Well, I'll go one step deeper now, but first, a little bit about scalability. We promised our customer, yeah, it will scale massively. If you read about Logic App, yes, it will scale massively, but we had to prove it. So after like 3 sprints, so like 6 weeks in the project, we said, okay, we want to do a stress test. We want to know what are the limits of our system. Can we get to 10,000 orders per hour? Well, we did a stress test. We ran it for 20 minutes. And in that 20 minutes, we were able to process more than 73,000 orders. That comes to about 220,000 orders per hour. There was only one order which took more than 3 seconds to be picked up by the system. Every other HTTP call to the system was picked up in less than 3 seconds. That was also very important for us because this typical web shop would re-trigger, resubmit the webhook if it didn't receive a 201 or 200 within 5 seconds. And then we had double orders and double order, etc. acknowledgements, so we didn't want that. So only one order didn't make it. Because of a little thing we didn't understand at that time, was that for the system to process all those orders, it took about 6 hours before they were all delivered to the marketing system, and also all the emails were sent from the marketing system. And we had some failure, a bit more than 1% failure, because somewhere in this setup we used storage, Azure storage, and we were throttled there. So, and then you can retry, but after 4 times the Logic App still fails. So because of the throttling on the Azure storage, we were not making the 100%. We run the same test in a low test situation with 10,000 orders, the required, and then we had 100% success rate. So I think this slide proves, yeah, it scales. Big time. No worries there. Cool. What did the solution look like if we would take one step deeper? What does it look like in the portal? You see here, now we have some Logic apps, a service bus namespace, some API connection, a storage account. And this is some of the lessons learned in this slide. One lesson learned is always use naming convention, like you're all experts on development. You have a name convention. Also, when you work Logic Apps or work with Azure resources, use a good name convention so you know what's happening. Also, another great tip, you can use tagging on resources. Probably most of you know, but one tag that helps a lot is the display name tag. And if you set the display name tag in a readable form, everywhere you can see your resource. You can also see the real value of the display name, like in the column on the right. And also, if you have their naming convention, it helps you in sorting and knows what belongs where. Like you see here, we have 3 core resources that use the whole system, and for each subsystem it connects to. So logistic service providers have some that belong to that subsystem. Marketing system and also the web shop have their own components. Display name, good tip. When we look at the orchestrator logic app, this is what the logic app looks like in the portal. It's just a workflow. Easy to read, easy to discuss with the business. This is something the business understands. If you show this in a demo, they say, yeah, no, okay. When you show them some C# code or F# code or whatever, they say, okay, I believe you. So this way of representing your code, and this is actually the code that runs, gives also the business a lot of confidence. It helps building confidence. Other top tip, always rename your actions. The suggested names are good, but always rename your actions to give even better insight what is happening. And like here, you see when the trigger fires, when the HTTP, when a message comes in from the web shop, we send out the 201 directly because of the 5-second rule. We map it and we publish it using other logic apps, nested logic apps. Now, let's look at the mapper. Now, also pretty readable. We process the order items. And we have some other stuff on the left side, right side, your right side. This is something you have to deal with when working with logic apps. I said the middleware we built was stateless. And logic apps helps you to stay stateless. Actually, it's hard to build in state in a logic app. It's very difficult. But sometimes you have to do a lookup, reference data, or etc. You have to add some data to the data you get from the web shop in this case. And that's something you have to solve. Now, you basically have three options. Use stable storage. Now that's what we did in the production system at the first place. That gave us the problems with the scalability. You can create like a JSON object directly in the logic app itself. Also works. A third option is use Cosmos DB or SQL Server to do a lookup, but if you scale massively, your cost will go up as well there. Finally, we compose the canonical order and we send back the result. Easy peasy. If we zoom into the composed canonical order, you see it's just building a JSON format from another JSON format. Easy mappings you can easily do in logic apps. Then we're going to put the canonical order on the service bus. And here we used, like I said, topics and subscriptions. This is a screenshot from the Service Bus Explorer. I highly recommend to use this one because the portal doesn't provide you with all the capabilities of the Service Bus. So top tip, use Service Bus Explorer when working with Service Bus. You see the topic, build 219 demo, order paid dev, so the development topic of the order paid event. And we have some descriptions for each LSP. So we have one for Austria, AT, Germany, Netherlands, UK, US. And we used rules to filter out or to determine which subscription gets which message. Because by using this way, We didn't have to build a large switch in a logic app. We used the capability of the service bus to filter out which logic app, which LSP gets which order. And the one at the bottom was the one for the marketing system, because all orders had to be sent to the marketing system. So it's also good to understand what are the capabilities of all resources. You have to do a lot of reading. To be able to use the filtering, that was a bit of a search. You have to put the things you want to filter on in the properties. See, right bottom, the properties of the send message action to the service bus. You have to put in the properties. Monitoring, yeah. This is actually a screenshot of the monitoring we used with the system, with the middleware. And this is all powered by Azure Monitoring and Log Analytics. When you connect your logic apps to Log Analytics, you can do powerful dashboarding. Actually, this dashboard was running on a monitor in our team room. We can monitor everything happening. We had a logic apps management at the top. That's a solution built by Microsoft, where you can see all the default things about logic apps. How many have run in the past 24 hours? How many failed? We had some failures. We knew we had some failures, but we didn't deal with them. About service bus traffic, right top is how many orders per hour per country there were. So you see the nice graph, and when we saw a dip in the graph, we knew, okay, something is wrong. And also, on one occasion, I saw a big spike in one of the countries, and I asked some guy, are you running a marketing campaign or something, or some special discount in that country? Oh, let me check. No, we're not. Oh, what's happening there? Because we have really spike orders there. Investigation, it was caused by a wrongly implemented discount rule in the web shop, which said, okay, the rules was supposed to be give 5% discount to the first 500 people, and they implemented it wrong. It was give discount 50. All the orders were kept on £50. So people were throwing things in a basket, but you still had to pay £50. And that went viral, as those things goes very quick viral. So a lot of people were ordering like basket worth £500-600 pounds, and only had to pay 50. And because we have this monitoring in place, we can catch it early, and no harm was done. So that was a very good case also for the monitoring. Why did we know some errors? Because, like I said, one lesson learned is don't try to fix everything within your middleware. The main failures we had here were people typing in their email address, wrong email address, like gmail.com instead of gmail.com. And the marketing system wouldn't accept those. It would throw an error. We could have fixed it in the middleware, but it's not the responsibility of the middleware. And when we had to fix it in the middleware, it would take a lot of time and effort to fix it in the middleware. You should fix it in the web shop. It's the responsibility of the web shop to filter out the wrong email addresses, not the middleware. To use Log Analytics, this is all based on Log Analytics and Azure Monitoring. To use it with with Logic Apps, it's very easy. You go down to diagnostic settings in the portal. You check send to log analytics, choose your log analytics workspace, and choose workflow runtime. And you can choose metrics. Most of the added value is from the workflow runtime. And what it will do, it will log every information on every workflow and every action that has run. Plus, to be able to create the top right, to know which country the order came from, you can add your domain properties also to the workflow, to the Logic App. It's stored together with the general information if the action or the workflow succeeded, when it ran, etc. You can add your own track properties, they're called. And you have to think about that, which one are valuable to monitor on. So in this case, order ID, it's easy to find problems. Shop ID, which was the country the shop was running in, which flow it belongs to, order paid, order shipped, etc. Also the customer email was very beneficial to have there, because of the last thing about monitoring is when you have this information inside log analytics, you can also run very powerful queries there. For instance, when a customer calls, I didn't receive an order confirmation. I just ordered something in the web shop, I didn't get a shipment confirmation. Customer care will say, okay, yeah, we see the order was sent in, but yeah, something happened. And then they call IT, and IT can say, okay, give me the customer email, like in the 4th row, my email address. I'm a very nagging customer, always calling. And then we get, from the last 48 hours, all the events the customer has done. And even have a link where we can step into that instance of the Logic App. Cool. Demo time. Okay. For this demo I have rebuilt the same system. You saw it also in the screenshots. This is the Azure portal. I have a nice dashboard where we have the Logic App solution, the management solution from Azure Monitoring. I can click on that, and we have some more insights just out of the box. How many have run, how many have failed, which one have failed, which actions failed, when did they fail. And you can even drill down deeper and deeper to the actual run itself. So that's very powerful. But stepping back, let's do an order. Let's make it so we can find it. So build 29, demo time. Something like that. I send it to the Logic App. Okay, we get a 201 created. So Logic App has received it, processed it, and we have to wait for the email. Okay, the email doesn't arrive. Let's see if the order for the LSP, I have your table storage where I throw it in. Let's see if it arrives there. Oh, looks like we have a problem. Something has changed in the meantime. Now let's see if the first logic app, it gave us the 201, has run. So let's refresh it here. We have a failed logic app. Easily spottable, red exclamation mark, it failed. We can look at that instance. What happened? We received the information. We can even see the payload, the total payload of the order received from the web shop, so that looks good. The response was sent. We saw that in Postman already. Oh, there was a problem when mapping. It retried 4 times. You can play with that. You can set it to 1. You can set it to different types of retrying policies, etc. We have a rule in my team: leave everything at the default. So you know you can change something when you need it. It's like when you're driving a car, you set it in drive. That's the normal. That's 80% of the times you just put it in drive. When it's snow, you do the manual shift. Or when you have in a bit of a hurry, you press the sports mode in your car, but normally you just set it in drive. It's with logic apps also. You have a lot of tinkering, a lot of settings you can play with, but I suggest just use the standard and only play with the settings when you need them. But yeah, there's something wrong in the mapping. And we can step into, now go to the next logic app, what happened. So this is the actually mapper that run within that other instance, within the main loop. And we see there's a problem in composed canonical order. And what we see here is first name was not supplied. I guess guys from the web shop, it's a SaaS solution, so sometimes they change, throw in a new version, sometimes something is mandatory, and then other times it's not. But first name is missing in this case. Okay, so we have to fix that. How do we fix that? Now, that's easy. We go to the logic app in the portal. We're on production. And I switch to the code view. You can also see it in Designer. But then you only have these kinds of things. You can't really edit it. So we go to the code view, where you can edit in JSON, and you can set up a little bit more settings. We find first name, and we see the question mark is missing. I have a code snippet that I can replace it. Oh, that's the wrong one. When it's null, it's not provided, I use an empty string, because I know later on I will use the first name to send out an email like, "Hi Aarjan, we received your order," etc. I'd save it. So I fixed the bugs on production. Yeah, happy. Everybody's happy, of course. We go back to the logic app, the main logic app, and there's one beautiful thing. We don't have to resubmit through the web shop the already existing order. We can replay it, resubmit the payload into the system. So we resubmit it, and now it should be green, yes, so it has been processed. Did we receive the email, please? Sometime, yeah, there it is. And also, it was received by this always takes a bit longer. It should be, come on, it should work. We look at that later. Cool. So now we fixed it in production. But, like all things you fix in production, We always forget to do it in development. We always do it in the development branch. So how we do that? So we switch over to our code. Here in VS Code, we deployed everything using ARM templates, Azure Resource Management templates. That takes time, takes some effort, but it gives a lot back. So here we have the same logic apps, same code. We see here the same code. We fix it here, same fix, save it, fix bug. It should be already, of course, there should be some bug reported, so we have to, we fix it. Yeah, and we sync with the master branch. Of course, you should do a pull request, etc., and everybody should look at it. I directly submit it to master. From there, a build kicks off automatically. The build kicks off, and after that, a release kicks off. And my fix is now on its way to development, where we can go through these steps of, okay, fix it, test it, acceptance, production. It takes about, the release takes about 5 minutes, 6 minutes. We're not going to wait for that. So we're going to switch back to the slides. Where did I put my clicker? So let me walk you through the CI/CD pipeline. Bit of a difficult picture. I tried to make it easier, but there's I had to do so many things in this picture. On the left, we have the developer context. The developer can choose work in Visual Studio, work in Visual Studio Code, in its own preferred editor, VI. I'm an old guy, VI. And our solution is made up mostly of 3 types of files. We have some PowerShell scripts we use, for instance, to set some defaults in table storage, etc., things you can't do with ARM templates. We have some .NET Core code for Azure Functions. We used Azure Functions, but only when logic apps, when we couldn't do the functionality in the logic app. For instance, if it takes too long or if it becomes too complex. For instance, we had to create an XML or a CSV file. Those things we step out to Azure Function, but the main control, the main loops we had in logic apps, because, like I said, you see how easy it is to follow what is happening in a logic app. And we had a lot of JSON objects, ARM templates, Azure Resource Manager templates. The developer could manually deploy them to the dev playground. Every developer has his own playground where he can test out things, script out new logic apps. And also, that's very important, test your templates. When he thinks everything is good, he does a pull request to the branch. The build pipeline, number 3, the build pipeline automatically kicks off. And what the build pipeline does mainly 3 things. It compiles the .NET Core code, of course, runs unit tests on the .NET Core code, and puts all the ARM templates in a blob storage somewhere in the Azure subscription. It had to be somewhere. We had a special resource group for that, where we do all the deploy stuff. Then the release pipeline kicks in when the build is done, build is finished. And the release pipeline tells the Azure Resource Manager service to deploy all the ARM templates we created to the dev test, acceptance, and production. This was our setup. What were the benefits and challenges with this setup? Benefits, of course, the normal CI/CD benefits you have. No manual steps in the deployment. Everything deploys automatically. You can do quality control. You can do quality gates, like with pull requests, etc. Different people accepting different steps in the release pipelines, etc. We could have a bigger development team. We could work on separate branches, and two devs can work on one feature, one can work on another feature. And because we're only making JSON files, PowerShell and C#, it merges. You can do it merges pretty good. So that's then you can do multiple things in one sprint. The downsides were, the release step is code for us because a lot of things are happening there. If there's a problem within an ARM template, you usually spot it only when you're doing a release. And for this simple demo, the release takes 5 minutes. The whole system took about 30 minutes. And then you know, when that fails, you have a pretty long cycle to get it right the first time. So it takes a lot of housekeeping around the ARM templates, putting all the parameters at a good point, etc. Experience helps here. We had in our team pretty steep learning curve, but when you have done it 2-3 times, you get this, you know what to do, and then it becomes better and better. And also, Microsoft tooling is also getting better and better on this point. For instance, the build is now a YAML build. YAML is also some sort of JSON, so that merges also pretty good. And they're also working on YAML release pipelines. So then we don't have to do it declaratively in the DevOps, but we can do it in code. And also, the rhythm of the service. Azure changes very fast, and sometimes things work, and sometimes after a while they don't work anymore because you use a preview version of something. Yeah, that's a choice you have. But most of the time it has really benefits to use the preview. How did we do? Did we make it? So how did we do? This is a picture taken from me during Black Friday. You can see the actual spike on Black Friday. We had around, the max spike was like 1,600 orders per hour. That was pretty good. The total of orders run during the Black Friday marketing campaign exceeded the total orders of the whole previous year. So the numbers were pretty good. And the number of incidents, 0. Actually, it was pretty boring. I had to be in the office at 7 every morning. And I just looked at monitoring and it was boring. But yeah, boring is good in this case. So I could think about the after Black Friday party we're going to throw. Some key takeaways. Logic apps, serverless integration, combination of logic apps, Azure functions, service bus. It gives you really fast time to market. Like I said, we have built the whole system in 3 months with 3 developers. It is pretty fast. It's really resilient and really scalable. Right? We've proven the scalability and also the resilience. In the whole period before Black Friday, we only had one incident we couldn't fix. And with the help of the Microsoft tax, we found out it was a really low-level infra problem in an Azure data center. It was like a port exhaustion or something. I don't know what that means even, but they knew. And when they fixed that, everything, no incidents at all. And I think with this case, we have proven that this technology is really capable of running really business-critical systems. That's it about for me. Please fill out feedback, and if there's any questions, we have mics if you have a question. We have 4 minutes left, so if there are any questions, please feel free. Otherwise, thank you for your attention, and have fun building logic apps.
Hello? Okay.
You have a question? Cool.
So I have a question. So I saw you had the monitor and dashboards. So is that how you know you have a problem? Do you always have to be watching the dashboards? Is monitor helping you out? And I mean, 10,000 per hour, I know that's your high end, but I mean, that's a lot to figure out to find the bad ones.
You have the dashboard. We can also set alerting rules. So we have on the critical flows, we have alerting rules. If you can set rules like if one or more logic apps fail within 10 minutes, please send out a text message or send out an email. You can automate also those kinds of rules. It's also in the Azure Monitoring capability as well. So you can proactively be...
So, but I would think every transaction is important.
Mm-hmm.
So you have to follow up on every bad one, don't you?
It depends. It depends.
Okay.
You can also automate that again. So when you have an error, for instance, shoot a ticket into the customer care system, and let customer care take care of it. Because when the user writes his email address, wrong email address, for us it's an error, because we get an error back from the system. But how you pick it up, that's your. Okay. But you have to know which problems can happen and which problems shouldn't happen. And when you see also like 10, 20 hours failing, then you know something major is happening. You have to come in fast.
You give your the business access to the Azure dashboard, or is it just the technical?
No, the business also had access to the dashboard. We created a separate dashboard for them, and also even because their financial system was also connected through Power BI, you can also export this dashboard, the log analytics and the Azure Monitoring. You can export it to Power BI as well, so they could also see, okay, this is my financial current state, and also how many orders were processed. All in one Power BI dashboard.
All right, I'll have to talk to you later about that.
Good.
So just a quick question. You touched on this, but in making the decision about Azure Functions versus Logic Apps,
yeah,
it looks like in this use case you kind of had some correlated orchestration that needed to happen between events within a particular container of logic. Is that what drove your decision that Logic Apps was more appropriate than this for functions that might be something more like a fire and forget? Like, is it a smell if you find yourself trying to orchestrate function calls and string them together on your own? Should you be looking at Logic Apps and you go down that path?
Actually, it was the cold start in functions, Azure Functions, that triggered us using a starting Logic App in the first place. On the hindsight, I wouldn't change it at all, because like I said, business understands what's on the screen.
Right.
Business doesn't understand. It gave a lot of confidence to them.
Right. It's much more expressive in terms of what's happening.
Exactly. And every time it gets more complicated, we stepped out to an Azure function. But the main flow was visible in Logic Apps.
Okay. Thank you.
I'm working with a customer that we're doing something similar,
Mm-hmm.
but migrating from BizTalk to Azure Logic Apps and Azure Functions. What did you do, or did you do anything with customer status? Because one of the things we're having an issue with is customers wanting status, and the issue between push-pull. When do we push status, and when do we pull it, and where do we, and not wanting customers to come all the way back into the infrastructure to be able to get status. So what we've done is really push status out to the edge. So we've got status as updates happen. We're pushing events out that update the table to status, and customers go to that to find out. And we're maintaining table storage of all the status changes. So if you want the latest status, you have the latest. If you want all the status changes as it goes through the process, that's out there, and it's pretty much how you want it. You know, you can kind of slice it, dice it the way you want it.
Yeah.
Have you guys done anything different or saying anything different? That
No, we left also all the state is in the edge.
Okay.
It's the responsible of the other systems.
Yep.
We're not responsible for state, we're stateless.
Okay.
And that was a good decision. That makes it so scalable.
Yep. Okay.
You have to be put your foot down to keep it that way.
Yeah,
and Logic App help because developers can't cheat.
Yeah.
They're stateless from themselves. They can't cheat.
Right.
That's about it for me. Sorry. Any other questions, please, outside the room. I will be there in 5 minutes. Thank you.